Well, hopefully everybody did a good job with practice 1, 2, and 3. So practice 4 and practice 5, when you first look at them, they may not look like there's actual categories, which is what makes these look a little bit tricky. So for practice 4, we're trying to figure out how many possible social security numbers that we can make. And so I gave a sample social security number just to see what one looks like. And so what we want to do is think about each individual digit as kind of being its own category. So what I do is sort of lay out exactly what a social security number would look like. So there's our first 3 numbers, our middle 2 numbers, and then our last 4 numbers. So instead of being clear-cut categories like we had above, A, B, C, D, the category 1, category 2 of toppings, in this case, we're going to think again of each digit as its own category. So when I go through and think about them, how many numbers can I put in between for that first digit of my social security number? So I can put any number between 0 and 9. So I've got 10 possible choices for what can go there. But technically I can use 0 through 9 for all of these. So I'm going to have 10 possible choices for each one. A lot of 10s here. And so, again, using our fundamental counting principle, we're going to multiply these guys all together. And so what I've got is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you know anything about exponents, this is the same thing as 10 raised to the 9th power, which is going to be 1. And we have 1, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we should have 9 zeros. 3, 4, 5, 6, 9. And so just to put them in there, so in this case it looks like we're going to have 1 billion possible social security numbers that we can actually make in this case. And then of course ask the question, do you think we'll ever run out? And so if you know anything about social security numbers, technically they haven't, at least up to this point, reused any of them. So because technically, if someone passes away, a family member still may be eligible for like Social Security benefits and stuff like that. So they haven't actually been reused up to this point. But there will come a time, that we are going to run out of those billion, and we'll have to figure out something else. Maybe throw in a letter somewhere, or start to reuse them at some point in time if ones were really, 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 really old. But all right, anyway, so for the practice 5, this one's kind of the same idea. So again, there's no obvious clear-cut categories, but we've got a license plate, and it consists of 3 letters for the first 3 parts, 3 numbers for the second part, and we want to figure out how many different license plates we can make, and we've got 2 different categories that we're using, or situations that we're using. So again, think of these in terms of categories. Let's lay out what the actual license plate would look like. So the first 3 boxes are going to represent our letters. The second 3 is going to represent our numbers. So if I look, so again, notice in this case, numbers and letters and numbers can be reused. So what that means is, since there's 26 letters in the alphabet, I've got 26 possible choices for my first letter. And since I can reuse them, I've got 26 for our second, 26 for our third. But now we want to move on to our numbers. So again, I've got 10 choices for the first number. And since numbers can be reused, I've got 10 for that, 10 for that. And then again, using our fundamental counting principle, we can multiply these guys together. And we get 17576,000. So we've got, looks like 17,576,000 ways to make license plates in this particular form that we have. All right. So finally, for the last one, we're going to trick it up a little bit. So we're assuming that letters cannot be reused, but numbers can be reused. So setups is still the same. We're going to use our little box method, lay out exactly what our letters and numbers are going to look like. And so since our numbers can be reused, this is not going to be any different from what we had above. We're just going to have 10, 10, and 10 in those spots. But for our letters, since we're not allowed to reuse them, then we're going to have access to all the letters for the first one. But let's say maybe the first letter we picked was A. Well, now I can no longer use A in my license plates. That gives me only 25 choices for what my second one could be, and maybe it's B. So now I can't use A or B, so I'm down to 24 possible choices for what I can use for my license plate. And so again, using our fundamental counting principle, we can multiply these guys together. And we're going to get so now we went from 17 million down to 15,600,000. So still a lot, but just by restricting whether you could reuse a letter or not, dropped it by almost 2 million possible license plates that we could actually make. So what happened is, even though we technically used the fundamental counting principle to answer part B, the fact that we were not allowing to reuse parts of it is actually what a permutation is. That's actually a good lead-in to what we want to talk about for this next section. So part B was really going to be what we're going to be covering in this next section, which is a permutation. So, all right, so let's come back and go ahead and talk about our permutations, since this was a good segue into it. So we've been given the job of scheduling the movie for the FCC Movie Marathon. We have 4 choices for movies. We've got action, comedy, drama, and horror. Luckily for us, we know the fundamental counting principle. How many different ways are there to order these 4 movies? So again, what we're going to do is think about like each category being a kind of a time slot. So maybe the first movie starts at 6 o'clock, the second movie starts at 8, the next movie starts at 10, and then the last movie starts at midnight. So each of these boxes that were drawn is going to represent a different time slot for which we can watch the movies. And so what we want to do is we want to go ahead and figure out how many possible ways we can watch these movies. So for the first movie, the 6 o'clock one, we could watch either the action, comedy, drama, and horror. So we've got 4 choices for what we can watch first. Now, technically, if you want people to stay, you probably don't want to play the same movie. If we played the action movie first and then followed it up with exactly the same movie, people are probably going to leave, and we want them to stay the whole entire time. So after we've watched a movie, we're going to throw it out and not watch it again. So in this case, we're going to drop down to 3 choices for the second movie. And again, assuming we don't want to watch any of those movies again, we're going to drop down to 2, and then finally to 1. So again, just like fundamental counting principle, except we're not allowing to reuse any of the elements. So if we multiply these together, 4 times 3 times 2 times 1 is going to give us 24 possible ways to watch these movies. All right, so again, example 3 and our practice 5, this very first part dealing with the letters, is exactly what a permutation is. So it's really fundamental counting without repeats, is the way to think about it. So in words, a permutation is an ordered list of items. So order is going to matter in this case. So because again, we rank these movies from the 6 o'clock up to the midnight showing. So we're not allowed to use items more than once. And then of course, the order of the list matters. So those are going to be when we're using a permutation. So again, think of it as a fundamental counting principle where repeats are not allowed. That's really what we're looking at. All right, so let's look at example 4 here real quick. So if we go back to the movie marathon, we know that most people don't like horror movies, so we decide that we're going to put it in the last spot. With that in mind, how many different ways are there to arrange the other movies? So again, let's go ahead and lay out our 4 time slots. And so in this case, what we're doing is saying, okay, well, we know we want to make the horror movie start at midnight, so let's go ahead and put it in there. So we're going to put H for horror movie because we know it has to go there. Well, now I've taken horror movie off the list, so I only have choices between the action, the comedy, and I'm trying to remember, drama. So that means I've only got 3 choices now for what the first movie could be, 2 choices for the second, and then finally 1 choice for the third. So now multiplying these together, so I've only got 6 possible ways I can arrange these 4 movies, assuming I put the horror movie in the last spot. All right. And so finally here we've got our example 5. So suppose we only have time to show 2 of the 4 movies. How many possible ways are there to order the 2 movies? So now maybe we were not allowed to do the movie marathon after 8 o'clock or something like that. So we've only got the 2, or 10 o'clock. So we've only got the 2 time slots, 6 and 8. So instead of having 4 time slots, we're down to just 2 time slots. And so I want to show just 2 of those 4 movies. So in this case, that would be 4 choices for the first, 3 choices for the second, and then unfortunately just 2 of the movies are not going to be able to be watched, which is okay. So again, multiplying these together, we're going to have 12 possible ways that we can schedule those 4 movies, choosing just 2 of them. All right, perfect. Very good, everybody. Excellent. So for our formula, so there is actually a formula that we can use for this. I don't really recommend using it. So, and there is a little calculator thing that I'm going to show you as well. But technically, you don't really have to use the calculator on these either, because if you use this box method, it's going to work all the time. But I will show you where it's at in case you want to see it. So if we look at our formula for a permutation, we've got all kinds of stuff going on here. We've got exclamation points, we've got things like that. So stuff you may not have ever seen before. So in a mathematic perspective, this 4 with the exclamation point after it is read as 4 factorial. And what it means is you start with that number and then keep multiplying down until you get to 1. So 4 factorial is 4 times 3 times 2 times 1. And again, I don't expect you to use this formula or know this formula or anything like that. But here it is just in case you're interested. And so in general, n is the number of elements total. R is the number we are choosing. So if we go back up above and kind of use this NPR notation, just in case you want to see it or use it or anything like that. So with this original one, we had 4 movies total: the action, the comedy, the drama, and the horror. Using all 4 movies, and in this case our R was actually 4 as well. So if we were to write this using our notation, we'd write it as 4P4, like that. So let me show you on the calculator where you can find this, just in case you do like to use the calculator for stuff like that and would rather not use the box method. So if we click over to our calculator, then what we want to do is go to our math button, which is underneath alpha, and then there should be an option for PRB, probability. And so if we look, number 2 is exactly that NPR button. So if we hit our NPR button, so it's asking me to put in the first number first, so in this case 4, and then our R was also 4, and so if I hit enter, so notice I get the answer 24, and if I look back, 24 was the answer that we had. So that works out perfect. Now, depending on if you have an older TI calculator, then if you were trying to do this on an older calculator, what you have to do is actually put the 4 in first, then go to math, then go to PRB, then go to NPR. And so mine still works this way too, which is nice. And then hit the final 4, and then hit enter. So some of them, you have to kind of hit the first number first and then do the NPR. before you can go on and type the next one. So just kind of keep that in mind if you're getting an error or if it doesn't seem to be working right. So message me and let me know so I can help you with it. All right, so if we look at the next one, so I'm not going to do this on the calculator anymore. I was just going to write out what it looks like. So for this one, since we placed the horror movie first, then that means our in, we only had 3 possible movies left. And since we placed all 3 movies, then our R would be 3. So in this case, this was going to be a 3P3 situation. And now for the last one, our N was again 4 because we had all 4 movies available to us, but we only put down 2 boxes because we only chose 2 movies. So for this one, our R is actually just going to be 2. So again, if we look at this from our little formula perspective, it would look like 4P2. All right, so again, you can use either the calculator or the box method, whichever ones you prefer for these guys. They both work perfectly. So let's go ahead. I'm going to have you guys work on practice 6, 7, 8, and 9. So again, don't use the formula. So either use the calculator or use the box method, whichever one you prefer, to answer these. And then when we come back, we're going to talk about combinations, which for this one we will unfortunately have to use the calculator on. That's kind of the only way to calculate them. So go ahead, work on these, and I will see you in a second for combinations.